We are now going to see a variant of AlexNet which will help us to understand the influence of hyperparameters in AlexNet and to comprehend the effect of each layer in the network. This new network is called ZFNet and was designed in 2013. ZFNet has the same structure as AlexNet. However, the feature maps are not split into two different GPUs. Thus, connections between layers are less sparse than the ones in AlexNet. The original paper is mentioned here. A fundamental tool to comprehend what activation feature maps are doing is the DeconvNet approach, which is the important ID in ZFNet. It aims at finding the pixels that maximize the activation of a given feature map. To do so, we are going to invert the network. Assume that we are given a trained AlexNet. Then, we choose in this network a layer and a feature map in this layer. We then run the network on a validation set and select the image whose activation for the given feature map is maximal. This can correspond to the image that maximizes the sum of all values of the feature map. Once this image is selected, we want to invert the network, that is, to start from the feature map associated to this image and to go back and try to find a stylized image in the original space. This procedure is displayed in the scheme here. On the right, you have the neural network. All layers are not depicted. We successively apply convolutions, ReLU and pooling. We will need to invert these operations. It is easy to invert a convolution, since the inverse of a convolution is simply a convolution. One cannot invert the ReLU function, but we can try to invert it by considering the identity function. The pooling step is more difficult to invert. This step is displayed below. Let us assume that we have the feature map on the bottom right. We apply pooling on it, so we obtain the feature map above, the pooled map. Now, assume that by going back through the network, you have managed to invert all operations so far, and you obtain the feature map named layer above reconstruction. It is difficult to reconstruct the 4x4 feature map since you do not know all the values that are smaller than the maxima, and you do not know where the maxima were in the feature map. Thus, during the forward pass, you are going to store the position of the maxima for each pooling layer, which allows you to place the value of the maxima at the correct location. You obtain the picture named unpooled map. Note that here, all other values are set to 0. We have managed to invert pooling by storing the position of the maxima during the forward pass. This is a 4x4 black and gray picture which represents the position of the maxima. Following this ID, we are now able to start from any given feature maps in the network and, in some sense, backpropagate this image through the network to obtain a stylized image.